Welcome students. Today we will discuss about the thermal property of heat, mode of transmission of heat, and in mode of transmission of heat we will discuss the conduction. Heat was previously considered to be a fluid called caloric which all body supposed to contain. However, the work of Count Rumford and some Sir James Prescott Joule proved that the heat flow is an energy transfer. The heat is defined as energy which is transferred from one body at a higher temperature to one at a lower temperature by means of conduction, convection, and radiation. Here we have a room in which a furnace is there, and the heat is transferred by all three modes here. Number one, by conduction through the wall of the room. And meanwhile, the hot air near the furnace became lighter and go ups to the colder region with the help of convection. And the cold air from outside the room is coming inside the room through window and doors by means of convection. And the third mode of transfer of heat is the radiation. It is electromagnetic transfer of energy. Now, here we will first read about the conduction. It is the phenomena of transfer of heat through one part of the body to the another, from particle to particle due to their vibration about their mean position, in the direction of fall of temperature without any actual movement of particle. In case of conduction, there is no actual movement of particles. There is a vibration between the particles, and the different way of conduction is by means of conduction of electron, by means of lattice vibration, and by means of molecular collision. The example of conduction are the hot utensil can be easily handled if they are of wooden handle, and our hands are saved from burning. So cooking utensils are provided with wooden handle. In winter, the metallic handle of door appear cold, as metal is a good conductor. Heat flow from our body to the metallic handle. In winter, Birds often swell their feather. Air enclosed between the body and feather does not permit the flow of heat from the body of bird to the cold surrounding. So there are some example of conduction. Now we will discuss how conduction produced by means of collision of molecules for amorphous solids, lattice vibration for crystalline solids, and conducting electrons for metals. For amorphous solids, some of the molecules which are at higher temperature collide with the molecule of having some lower energy. When they collide, they transfer heat. The high energy molecule transfers some amount of heat to the lower energy level of molecule, and the energy is transferred to the lower molecule, the lower temperature molecule, and lower temperature molecule gets some energy. And by this means, the molecular collision will provide the conduction. The another way is conduction by lattice vibration. If we consider about the crystal solids, the lattice are regularly arranged and the particle from hot side molecule gives the energy to the lower one. And by this means there is a vibration between the lattice position of the crystal, and this vibration provide the energy to the nearby crystal lattice. And by this means the energy is regularly passes to the other molecules by means of lattice vibration. In third condition, here is a metal, and in a metal there are so many number of free electrons, and when heat source is near them, the electron take place, the energy, and they are in motion, and they gives the heat from one side to another side. Here we have a metal rod, and the atoms are closely packed, and heat is provided to this rod. The metallic rod is now being heated, and what happened? The energy is transferred to the atoms, and vibration of the atom started. Here, at red position, the vibration are started. In third condition, the vibration are increased and the energy is transferred to the other atoms in regular way. Now, the next point of interest is the temperature gradient. If we take a rod of any length and insert two thermometers at two different points and heat the rod from one end at steady state condition. Steady state condition means the Neither the rod is absorbing heat from other side or sink from them. The heat is only transferred from hot bath to the cold bath. Let us consider here is the hot bath with having temperature theta 1 and the cold bath having temperature theta 2. So the heat start to transfer. Now let us consider the 2 points between the rods and they are A and B. They are placed at a distance dx and temperature of one of them is theta 1 and temperature of other is theta 2. It means there is a temperature difference and theta 1 is more than theta 2. Then the fall or rise in temperature per unit length is represented by d theta by dx. D theta is the temperature difference between the point A and B, and it is theta 1 minus theta 2. And the separation between the point is dx. The rise or fall of the temperature per unit length is called temperature gradient. Its unit, if temperature is measured in Celsius and distance is measured in meter, then its unit will be Celsius per meter. If temperature is measured into Kelvin, then it will be Kelvin per meter. It is a vector quantity and its direction is from low to high temperature. Now, next point is thermal conductivity. Let us consider a rectangular bar of uniform cross-sectional area A. Here we are taking a bar and it is rectangular in shape and the cross-sectional area of this bar is A. The length of this rectangular bar is D. D is the length of rectangular bar. And the solid is in steady state. It means there is no absorption or no sink is there. Only Q heat is transferred from the surface area A to the surface having temperature theta 2. Here temperature of surface A is theta 1, which is at hot temperature, and theta 2 is at lower temperature. Heat is conducted through the solid from hot phase to cold phase. Let dq is the amount of heat conducted for a very small time interval dt. Now here we are using the heat which conducted is dq and it is a very small amount of heat for the time duration dt. The time duration is dt. Then the rate of conduction of heat. The rate of conduction of heat will represented by dq by dt, and it is directly proportional to cross-sectional area. More the area, more the rate of conduction of heat. And it is also directly proportional to the difference in temperature between two phases. If difference of temperature theta 1 minus theta 2 is more, the heat will transfer more. And if theta 1 minus theta is less, the heat will transfer less. So the rate of conduction of heat is also proportional to the difference of temperature, or we may write dq by dt is proportional to theta 1 minus theta 2. Same time, the rate of conduction of heat dq by dt is inversely proportional to the distance between the two faces of solid rod. So dq by dt is proportional to 1 by d. It is also depend on nature of the material of the rod. The rate of conduction is different for different material. For good conductor of heat like copper and silver, while other are poor conductor of heat like wood and glass. So the rate of conduction of heat also depend on material. The metal is a generally good conductor of heat. So we may write the equation for rate of conduction of heat as dq by dt is proportional to a theta 1 minus theta 2 divided by t. Here rate of flow of heat is proportional to area, the temperature difference of between two phases, and inversely proportional to the distance between them. Or we may write here dq by dt is equal to k a theta 1 minus theta 2 by t. Here k is the constant of proportionality, and this constant of proportionality is called coefficient of thermal conductivity of the solid. So K is depend on the nature of material. The K is proportionality constant and this is coefficient of thermal conductivity. So K may be written as dq by dt, that is rate of conduction of heat, divided by area A, temperature difference theta 1 minus theta 2, into D. D is the distance between the plates, the faces of the solid. The coefficient of thermal conductivity of solid is equal to the rate of flow of heat per unit area per unit temperature gradient across the solid. How we say this one? We find out the value of K, that is coefficient of thermal conductivity, and it is dQ by dt into D divided by A theta 1 minus theta 2. So K is equal to the rate of flow of heat. K will be equal to dQ by dt when, that is rate of flow of heat, when the area is unit. In place of area, we are writing here 1 meter square. Theta 1 minus theta 2 is unit temperature difference, and the length is 1 meter. So K is the rate of flow of heat for unit area, square area, unit temperature difference for unit separation. So it is defined as the amount of heat. It is defined as amount of heat. It means K is defined as heat. K is equal to dQ. It means now we are trying to write here time is also 1 second. Time is also 1 second. So the coefficient of thermal conductivity K is equal to the amount of heat which flow in 1 second through the opposite faces of block whose area of cross sectional is unit and distance between them is unit. Maintain a temperature difference of 1 degree Celsius. So this is all about the coefficient of thermal conductivity K.